Oh, hello. I'm back. How are you? Let's see what this thing does, guys. I'm going to get right into the coverage. I already have the coverage open, so. All right, return to flight mission here for Rocket Lab. Let's see what we got.
Photon will change the way that science is done by having more regular science missions that are more affordable, increasing opportunity for everyone.
It's a little Chile up here.
Photon's a really unique platform, so it's able to be configured into a low Earth orbit configuration to do really important low Earth orbit missions. But also we can juice it up and take it to far destinations, whether it be the moon or other planets or even further out.
We have several planetary missions in development today. Later this year, we'll launch to the moon with NASA for the Capstone mission, which is the first launch of the Artemis program. Then we'll move on to Mars with 2 spacecraft for the NASA Escapade mission. And we've also announced a privately funded mission to Venus to search for life in the atmosphere.
Oh, I love Venus the most, for sure. I mean, Mars is great and all, and the moon's pretty awesome, but Venus has the potential for life. And if we look at our near-Earth objects, I mean, Mars potentially had life, and who knows what we'll find there, but Venus is incredibly, understudied, and I think there's a tremendous amount to learn. And if you look at Venus and Earth, they are the 2 closest planets to each other, and Venus is just Earth gone really bad, so wouldn't it be good to go and take a look at that?
Photon is a very flexible spacecraft. It's not designed as a standard or commodity bus. Every aspect of Photon is configurable for the mission, from the propellant tank sizing to the selection of engine or the communication systems. This allows us to meet the challenging requirements of these various different missions. So the secret to Photon doing planetary missions is the Hypercurie engine, a high-performance in-space engine that we have in development for the Capstone and Escapade missions. Beyond planetary missions, Photon will enable a range of capabilities, from single spacecraft to constellations, telecommunication satellites, remote sensing and weather, and even orbital transfer and maneuvering vehicles. But most exciting are the payloads we haven't even thought of.
Yeah, if you're a planetary scientist, I think Photon is kind of your ticket to all of the planets and into our solar system. No, I mean, we've got the trifecta in the near-Earth objects, but there's many, many more destinations that we can take it. So perhaps we should add an asteroid to the list.
There's never a dull moment here at Rocket Lab, and we can't wait to visit many more destinations in our solar system. But back to today's mission, and we're not far away now from a critical point in the count, the switch to the auto sequence in the lead up to launch. We have finished loading Electron with liquid oxygen, and at T-minus 2 minutes, Electron's flight computer will take over the final phase of the countdown. Shortly after that, at T-minus 1 minute, we can expect confirmation that the launch vehicle's first and second stages are pressurized for launch. And then finally, at T-minus 10 seconds, that all-important final countdown will start ahead of engine ignition. Let's hand over now to Mission Control and listen in on the final moments until liftoff.
All right. It's a return to flight mission, guys. So let's see what happens. T-minus 2 minute 20. What is return to flight? The last one broke.
Vehicles on internal power.
Okay, they've cut the vehicle off from the grid. Has pad deluge systems. No. They seem to be. I don't know if that's. I forget if that's normal, guys. I haven't watched the Rocket Lab launch in a long time. There seems to be LOX leaking out over there. It could be just gaseous oxygen. It could be venting on purpose.
System in recirculation.
Huh. That didn't do that before. It looks like they've changed a lot of things. Yeah. I don't remember Electron having vents like that. What they're doing is they're messing with the tank pressures by venting gaseous oxygen.
Disabled.
Okay, the guys are... Okay. Arc Heaven is 32 months. Where's this launching from? The Mahi Peninsula in New Zealand.
Stage 1 and Stage 2 are pressed for flight.
High flow engine purge is enabled.
Okay, there's the sound suppressor online.
Deluge is activated.
T-minus 30 seconds. Yeah, they have made some design alterations for sure. T-minus 20.
T-minus 20 seconds.
Ten.
10, 9, 8, 7, 6.
Headphone users.
5, 4, 3.
Headphone users.
2.
Go, baby, go! Great audio.
We are off the pad and on our way to space once again with successful liftoff from Rocket Lab Launch Complex 1. Right now, Electron is traveling at over 500 kilometers an hour and is passing 3 kilometers in altitude. Very soon, Electron will approach max Q, or maximum dynamic pressure, that moment when forces are at their greatest on the launch vehicle. Let's listen in for the call from Mission Control that Electron has passed that phase.
Stand by for Mach 1.
Vehicle is supersonic.
There it is.
Approaching max Q.
Yeah, right, Prey. Definitely a different noise. They have electric motors spinning the fuel pumps of the rocket engines. That's why it's like instant rocket.
Cleared max Q.
Okay, through maximum dynamic pressure, that's peak aerodynamic load on the vehicle.
There's the call out. Electron has successfully passed through max Q. Propulsion is continuing nominally on the first stage as we approach the next event, Electron's ascent.
Okay, note as they get higher up in the atmosphere, the exhaust plume coming out of the first stage expands because of the lower ambient temperatures. See? The plume's getting bigger and bigger and bigger.
Altitude is 30 kilometers, speed is 1.3 kilometers per second.
AOS Chatham Station.
First up, the 9 Rutherford engines will throttle down before shutting off completely, otherwise known as main engine cutoff or MECO. Shortly afterward, we'll see separation of the first and second stages, followed quickly by ignition of the single Rutherford engine on Electron's second stage.
15 seconds to go.
Go with Dawson guest star on NASA spaceflight? Might have to ask. Stand by for main engine cutoff here in a second. There's the throttle down. That's what. See the plume changed? Engine cutoff confirmed. Stage separation confirmed. Stand by for upper stage ignition. Perfect. Good. That was the point where the last mission failed, right there. That's why everybody's cheering.
As you've seen, we've had a successful MECO, stage separation, and second stage engine ignition. Next, we'll be coming up on fairing separation. This is when the two halves of Electron's fairing separate and fall away in preparation for payload deployment.
Fairing succeeded.
And there it is, you saw a flash of it on your screen. The fairing has separated, clearing the way for payload deployment coming up in approximately 50 minutes from now. Meanwhile, stage 2 is continuing well to orbit, carrying the kick stage and the Monolith satellite.
The Monolith satellite, Pixel. I forget what it's for, dude. I'll be honest with you.
Guidance is nominal. Altitude is 140 kilometers. We are flying with 3 kilometers per second.
the clap parameter emote is so good. Okay, everything's looking good.
And we are looking at a healthy stage
It's a Space
2
Force
burn
stat.
at a few minutes
Got it.
and 4 minutes and 5 seconds into the mission. At an altitude of about 10,000 plus kilometers and a velocity of over 165, Electron continues nominally. At a healthy stage 2 burn at a few minutes and 4 minutes and 5 seconds into the mission. At an altitude of about 10,000 plus kilometers and a velocity of over 165, Electron continues nominally. Successfully left the pad. We're in the middle of our stage 2 burn, taking us to an elliptical orbit, after which the kick stage will separate in preparation for payload deployment. All systems continue to work.
Taylor, I listened to it. I'm like, wait, what? 10,000 kilometers up? What, did they invent warp speed or something?
So for those of you
Oh, okay,
just
IQ,
joining
there you
us
go.
on our 21st mission, you will have heard from Mission Control that everything is continuing nominally during our
Hey
second
man,
stage
I can
burn.
say doing a live
Ahead of
gas, it's
kick
really
stage
easy
separation
to
is the
switch
battery
things like
hotspot,
that. That does,
coming up
dude,
in about a
you won't
minute.
even notice
On
yourself
our way
doing
to
it.
orbit, we are traveling at a speed of over 13,000 kilometers with an altitude of over 200.
See, she said it right that time. Dude, I do that all the time. I flip numbers like that. That absolutely does happen.
Now for one of the events of the launch events unique to Electron.
watch
the
this thing on the
battery
right.
jettison. The fuel pumps in Electron's Rutherford
know,
engines
T-Man.
are powered by batteries. But once those batteries are depleted, it's just added weight that we don't need to carry all the way to orbit. So we swap out the depleted batteries for a fresh new one
Throttling down.
to keep Electron's second
Okay.
stage going all the way.
Ready?
We call this
Click.
maneuver battery
Bye-bye.
hotspot, and it's coming up next.
Confirmed.
So, because the
And there
electric
it goes. You will have just seen it falling away.
Because the engines have electric motors that are powering the turbo pumps. Because of that, they actually have batteries because they're electric motors, right? And just like how a rocket would jettison a stage of empty fuel tanks, Rocket Lab jettisons the batteries once they go dead. The batteries, they jettison the batteries and they actually make the stage lighter. They hot swap the batteries to batteries that are fully charged, and once one of the sets of batteries gets depleted, they jettison them. That's what you just saw. It's actually really neat.
On your screen there is the glowing hot vacuum optimized nozzle for the Rutherford engine
It's
on
a bladed
Electron's
spaceman,
second
yeah.
stage. It's the same base engine that we use 9 of on the first stage to do most of the heavy lifting. But when we're in space, we only need one. The vacuum optimized nozzle extension allows us to match the pressure of the environment, unlocking some 5,800 pounds of thrust.
Okay, everything's good. Yeah, there you go, Panta. Yeah, see, it happens, dude. I flip stuff all the time. It's just nice to see other people doing it. That's why I was laughing. That's why I found it funny. I'm like, wait, what? Oh, I do that. Cyborg. Very nice, very nice.
HVB battery discharged holding nominal.
Okay.
Electron's second stage is now approaching SECO, or second engine cutoff. Much like main engine cutoff, the stage 2 Rutherford will throttle down before the kick stage separates ahead of payload deployment. We are now 8 minutes and 13 seconds into flight, and everything is looking great for payload deployment in approximately 45 minutes.
Guidance is in terminal, 20 seconds remaining.
Stand by for second stage engine cutoff.
Stage 2 shutdown.
Looks good.
Stage 3 separation confirmed. And nominal cancel orbit achieved.
Yeah, I know why. Peter Beck in the back there.
And that confirms Electron's second stage engine has shut down and the kick stage and second stage have separated. So the kick stage will now enter what we call a coasting phase while it's in an elliptical orbit before its Curie engine ignites to circularize the orbit ahead of payload deployment. Now, we won't have a live video feed from Electron of payload deployment on this mission, but we will stay with you on this webcast to bring you a simulated view of that happening. We'll take a bit of a break on the webcast now, but we'll be back with you closer to payload deployment to listen in on those final moments from mission control.
Cool.
Payload deployment is expected to take place at about T plus 52 minutes, so we'll see you back here then.
What's the payload? It's satellite for the Space Force. Yeah, it's Timmy's music, dudes.
So for anyone interested, I'll read out the orbital elements. Our target energy was 603.8.
Right, Hypno.
605.15. Target PRG 246.8. We're at 245.6. And the inclination is bang on.
Timmy's got good music, man.
So we're on track for a really tight.
Zero difference between the engines that are used on the ground, like the Merlin engines, and the engines that are used in space. Yeah, the nozzle. The nozzle is different, Niroku. You need a much bigger nozzle up there. The reason why is because the pressure, the ambient pressure. The ambient pressure up there is lower, so you're going to need a nozzle with a bigger, what's called an expansion ratio, or just a bigger nozzle. You just say a bigger nozzle. This is the simplest way to describe this. Now, keep in mind, it's the simplest way. I know about propulsion for the folks that are going to be like, what? Just chill, all right? So when a rocket engine is down here, you can afford to use a shorter nozzle, right? And because you can afford to use, you can do that because basically the pressure of your ambient pressure of all the air keeps the gases coming out of the rocket in a nice column. They stay in a nice column. Ideally, they kind of do a little bit of an hourglass thing, and that makes shock diamonds inside of it. But you really, down here, you can afford to have a smaller nozzle because the gases can stay in a nice column. Up there, the gases just expand forever because basically you're in a vacuum. So you're going to need a bigger nozzle to at least help propel the gases from the engine away from the vehicles. You need a little bit bigger nozzle. That feeds into something called plume over and under expansion, or flow separation inside of the nozzle due to underexpanded flow, and yeah, it gets complicated. When does it not? But long story short, yeah, the nozzle is the biggest difference between a first stage and a second stage engine. What's up, Roblox? Where in New Zealand was this launched? The Mahia Peninsula? Geothox? What time is the Boeing OFT? It's not tomorrow, it's on Friday at 2:56. There's a gimbal on this engine. Yeah, they gotta steer somehow. Are all the mechanical parts the same between first and third stage? Yeah, for the most part. I mean, some rockets don't have commonality between the first and second stage engine. An Atlas V using an RL-10 in the upper stage and an RD-180 in the first stage, those share no part commonality at all. M1D vac, or Merlin vacuum, is derived from the Merlin 1D. It's pretty much a separate engine at this point. That's why they call it MVac and not M1D vacuum anymore. But yeah, those are all derived from common machinery as well. But it sounds like a turbo pump spinning up. Hey, DJ.
Now back safe and sound.
Stage 1 and Stage 2 high voltage batteries are ready for...
That's not a turbo pump. It's a siren. It's the warning siren. That's all. Raptor's insane combustion pressure allows it to use essentially the same power head for the Vector. Prey, what still blows my mind is that they can test Vector engines down here and not have to worry about an overexpanded plume, which is ridiculous. I mean, Raptors are insane. I mean, yeah, generally you can't test fire a vacuum nozzle down here, it'll explode. Because you'll get plume over expansion and flow sep inside of the nozzle. I don't know if there's any videos of it around, Jason. SpaceX might have a video somewhere, dudes. But anyway, guys, I would love to stay with you for the rest of the mission here. Just barely. They have some flow separation, but some chunky stiffeners. Still insanely impressive that a sea-level powerhead can fill a vacuum nozzle. Yeah, for sure, man, for sure. Guys, I'd love to stay with you. I'll be 100% real. I want to go to sleep because we have to get up for Nauka. The Nauka launches in 6 hours, and I need to get some sleep. So, well, a missed electron from a tornado. Oof. Yeah, they're not going to show separation with this mission, but it's good to see that they did have a nominal return to flight. The mission got into orbit, which is good. I'm really happy for Rocket Lab. That's amazing. No sleep for you, only rockets. I will see you guys back here.